Example 9M. So a fair coin is tossed 3 times and we're asked to define the following events. So A is the first toss is heads, B is the second toss is tails, and C is that exactly 2 tails are tossed in a row. In a row is important, we'll get to that a little bit later. The question that we're actually asked though is which of the pairs of events are independent? So our step 1 is to write out all possible outcomes. So this is all possible outcomes of throwing or tossing 3 coins. So all of our possible outcomes that we have is heads, 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 tails, heads, tails, heads, head, tail, tail, so forth, so on. So once we write them all out, you should have a total of 9 different outcomes that you could possibly get. Next, we're going to write out all the possible outcomes for each of the individual events. So event A, which is tossing the head, first toss is a head. The possible outcomes which are correct are the first 4. So we'll just write those ones out. The second event is the second toss is tails. So there are again 4 possibilities of that. The third event is that exactly 2 tails are tossed in a row. So 2 tails are tossed in a row. That does not include tails, heads, tails, as they're not tossed in a row. So there's only actually 2 possibilities for that. Next step is to write out the probability of each of these events occurring. So there are 4 outcomes for probability of A out of a total of 8, so 4 eighths, 1/2. Same for the probability of B. Probability of C is 1/4. Now we're looking at doing the intersection of A and B. So what's in common between the events A and the event B? So in this particular case, I've got HTH here. It should actually also have HTT. They both occur in the events. So there should be 2 outcomes here, and there's not. The intersection of A and C. So what's in common between A and C, which is HTT. So there's only 1 event. And what's in common between B and C, which is again HTT, but it also includes TTH in that particular case. So calculate the probabilities of each of these outcomes. As I've done this incorrectly, I'm about to do 1 out of 8, which will mean this is actually incorrect. It should be 2 out of 8 or 1/4. Either way, I've gone through and I've used it that way. So these are the probabilities that I've gotten out. Now, the checks for independence. We have that rule that we found last time, which said that for them to be independent, the intersection of the probability of A and B, or probability of your 2 events, has to be equal to the probability of the event 1 times the probability of event 2. So we know the intersection, or the probability of intersection of 1 of A and B is 1/8. It should actually be 1/4. And we know that the probability of A is 1/2 and the probability of B is 1/2. So in fact, this should be independent. Probability of A and B are independent of each other. So this should be equal to, and that's a 1/4. A and C is going to give you an independent event again, and B and C is non-independent, hence we would say that that is a non-independent event. So the 2 that are independent are A and B and A and C, but B and C are dependent on each other.